So today we're going to be starting on lecture covering section 1.1, which is linear equations. Virtual learners or learners that are at home, you all should hop over to the high school's Canvas and make sure you fill out the attendance check. So let's make sure to do attendance check. In the high school Canvas. That'll get you credit for being in high school for the day in high school, and get you credit for college. That you were here for the day for the college class. All right, so example one, we're just going to cover a couple examples from the book. So example one gives us wants us to solve 3 times 2x minus 4 equals 7 minus x plus 5. So this is what we're trying to solve. What we're going to do is we're going to distribute the 3 first to get rid of this parenthesis. So 3 times 2x is a 6x. 3 times negative 4 is minus 12. That equals 7. And on this side, we have to distribute the negative sign. So that'll be 7 minus x minus 5. We'll combine like terms, so we get 6x minus 12 is 7, take away 5 is 2, so 2 minus x. We're going to go through and get all the x's on one side, so I'll add the x across. It'll cancel over here. And this negative 12 that doesn't have an x, I need to add to both sides positive 12 to move it back across. So 6x plus another x is 7x. That equals 2 plus 12 is 14. To finish up, we're going to divide the 7 across to get x completely by itself. When we do that, we get x is positive 2. So that one is just going through using the distributive law. And then when we want to move terms back and forth across the equal sign, we just use that if we add the same amount to both sides of the equation, we can get things to cancel. And our goal is to get the x by itself, and we did. So that's going to wrap up example 1. Example 2. We have 2x plus 4, all that over a 3, plus a 1/2 times an x equals a 1/4 times x minus 7/3. We want to solve this. And I don't want to solve this with fractions. So what we're going to do is we're going to find what's called an least common denominator. So we're going to look and think what's the smallest number that 3, 2, 4, and 3 again will divide into. And if we think about it a little bit, we'll come up with 12 is the smallest number that all of those numbers divide evenly into. So what we're going to do is we're going to multiply the whole top of the equation through by that least common denominator 12. So we're just multiplying every single term here through by 12. And that's going to let things cancel out. So 3 will cancel into 12. That'll leave a 4. So our first term is going to be a 4 times the 2x plus 4 that's still there. The next term, the 2 can cancel with the 12. That'll leave a 6 times a 1 times an x. So that will be a plus 6x. That will equal the 4 can cancel into the 12. That'll leave a 3. So this is 3 times 1 times x. So that would be 3x. And on the final term, the 3 can cancel into the 12. That'll leave a 4. So we get minus 4 times 7 is 28. So we need to distribute the 4 is the next step here. We got to get rid of this parenthesis. So that'll be 8x plus 16 plus 6x equals 3x minus 28. 8x plus 6x is 14x's. So we're going to combine like terms and just get all x stuff combined together here. And then from this point on, I need to get all the x information on one side of the equation. So I'm going to use that I can subtract 3x from both sides of my equation. That will leave the equation still being balanced. It'll cancel here. And I can subtract 16 from both sides of the equation, and the 16s will cancel. So 11x take away 3x, or sorry, 14x take away 3x is going to be 11x. That will equal, we have negative 28, we take away another 16. So if we do negative 28, take away 16, that's going to end up being negative 44. And now we can divide the 11 to get the x completely by itself. And negative 44 divided by 11 is negative 4. So we get x, in this case, is just negative 4. So if you have fractions involved in the original statement, you can find the LCD, multiply the whole equation through by the LCD. And if you really did find the LCD, all the fractional parts, the denominators will cancel evenly into it, and you'll be left with a statement that has no more divisions. So the next thing, we have a couple of terms we need to identify. So equations can be either an identity. So this is an equation that is always true. Like we could say 3x plus 6 is equal to 3 times x plus 2. Just this equation is true for every single x. Like if you distribute the 3, you can see that this side's 3x plus 6 and that side's 3x plus 6. So it's really kind of the same thing on both sides. So this would be true for every single x. We have a conditional equation. This is an equation that is true for some x's. True for some x's, and it's false for others. So this is an equation that's sometimes true. So an example would be like 2x equals 8. If x is 4, the equation's true. If x is another number like 5, 2 times 5 is 10, 10 is not equal to 8, the equation's false. So a conditional equation is an equation that's sometimes true, and a contradiction, that'll be an equation that is never true. So an example of the equation that's never true, we could say like if we had 2x plus 2, and that equals 2 times x plus 3. This side, if you distribute, is 2x plus 6. This side's 2x plus 2, so they're not the same thing, and no matter what x you choose, this one's always going to be false. So the next example is going to have us go through and try to classify our equations as identity, contradiction, conditional equation, or a contradiction. So we'll look at example 3. We got first equation that we want to classify is negative 2 times x plus 4 plus 3x equals x minus 8. So this is our first equation. Let's go through and see what it turns into. So I'll distribute the negative 2 first. I'll get negative 2x minus 8 plus 3x equals x minus 8. On this side, negative 2x plus 3x is a single x, so we get x minus 8 equals x minus 8. This is always true. This is true for all x's. So we could say always true. So this is an identity. So let me do the next part in a different color to kind of keep stuff straight as to what equation corresponds to what. So part B gives us 5x minus 4 equals 11. So we're going to try to solve this through and see, is it always true, sometimes true, or never true? And then depending on that, will either be an identity, a conditional equation, or a contradiction. So I'll add 4 to both sides to start getting the x by itself. Let's see, 4's cancel. 11 plus 4 is 15. We'll divide by 5 on both sides. 5's cancel here. We get x is 15 over 5 is 3. So this is sometimes true. This is true whenever x is 3. It's false otherwise. So this is conditional equation. So that being a conditional equation, it's an equation that's true some of the time, false others. All right, then the final one, part C. We got 3 times 3x minus 1 equals 9x plus 7. So to start out, we'll try to distribute the 3. So we'll get 9x minus 3 equals 9x plus 7. We'll go through and subtract 9x from both sides. And we'll note the 9x's cancel. And we're left with negative 3 equals 7. Well, negative 3 is never 7, so this is never true. So this is a contradiction. Okay, so we've hit on everything that we needed to for that one. We took all 3 of the parts that they gave us, and we classified them as always true, sometimes true, never true. Okay, moving along to the next example. This one also has multiple parts. It wants us to solve each equation for a given value. So part A, they give us the equation I equals P RT, and we want to solve this for T. So what that means is get T by itself on one side of the equation and everything not T on the other side. So what we have is P and R are multiplied to T, so we need to divide by those variables to move those variables across the equal sign. So when we do that, P's cancel, the R's cancel, and now we get I divided by P times R is equal to T, and our T is isolated, so we have the equation solved for T. Okay, so moving on to part B. Give us a slightly different equation. A minus P equals PRT. We want to solve that for P. So the first thing I need to do here is I need to get all the P values on the same side of the equation. So I need to add this P across the equation. So that will leave the A by itself. I'll have P times R times T plus an extra P. So both these terms on the right-hand side both have a P in it, so we're able to factor those P's out. So we'll get A equals RT plus 1, and we factored out the P. You can check if you distributed the P from this step, you get what was stated in the previous step. So we got this all worked out okay. Now our goal is to get the P completely by itself. It's being multiplied by RT plus 1. So we need to divide both sides by the whole term RT plus 1. Now here we'll divide by RT plus 1. We'll cancel there. We'll rewrite our answer. A divided by RT plus 1 is P. So now that we have the P by itself on one side of the equation, our equation is solved for the variable we were looking for. Okay, final one is part C. They give us 3 times 2x minus 5a plus 4b equals 4x minus 2, and our goal is to solve this for x. Okay. So step one, we need to get everything out of the parentheses here. So we're going to distribute the 3. So we get 6x minus 15a plus 4b equals 4x minus 2. So now I need everybody that has an x in it to get on one side of the equation. So I'm going to gather the x's over here. In order to do that, I will subtract 6 x's. So the 6 x's will cancel here. And this negative 2 that doesn't have an x, I'm going to add it back across. So it cancels on this side. So what we currently have is negative 15a plus 4b plus the 2 that we moved over equals 4x minus 6 would be a negative 2x. So to get the x, we're supposed to solve for x, so that means get it completely by itself. I'm going to divide all the terms of the equation by negative 2 and then simplify the ratios down that I get. Negative over negative is positive. 15 over 2 doesn't really turn anything nicer, so we'll leave that as 15 halves times a. 4 divided by negative 2 is negative 2, so the next term we have negative 2b. 2 divided by negative 2 is a negative 1, and that equals negative 2 over negative is positive. 2 divided by 2 is 1, so that equals x by itself. And this is our answer. We have that equation solved for x. So, final equation from your book. I'm going to get this last one here done for section 1.1. We have a woman borrowed $5,240. $5,240 for new furniture. Okay. She will pay it off in 11 months. At an annual interest rate of 4.5%. And we'll say, how much interest does she pay? Okay, so for this problem here, we're going to use a simple interest formula. I equals P times R times T. And what we have to do here, in this problem, I is going to be the amount of interest. P is going to be the principal. That's the initial amount that we, or that's the amount we borrowed. So that's going to be $5,240 for this case. R is the interest rate. We have to write the interest rate as a decimal. So we have 4.5%, which will be 0.045. And the time, we need time in terms of years. So if you have 11 months is 11/12ths of a year. So we're going to use the fraction 11/12ths to get the interest. So what we end up when we put this together, we got 5,240 times 0.045, all that multiplied by 11/12ths. So we're going to use a calculator here, and we're just going to type that in. 5,240 times 0.045 times 11 divided by 12, and we end up with $216.15 would be how much interest that she paid. Okay, so that is going to wrap up section 1.1. So we'll stop the video here, and we'll move on to the next one in a little bit.